Hi everyone, my name is Irina Niculescu and together with Mary Hu, we would like to present our paper towards inclusive software engineering through A/B testing. First, we would like to thank all our collaborators, Christina, Chewy, Shivam, and Paul Lee. Engineering features to be inclusive of all those that might, could, should use it is important. However, today, data used to engineer these features can have inherent biases with inclusiveness concerns. For example, gender identity. Using real-world data from the Windows out-of-the-box experience, the UBI feature, we present a case study of how inclusiveness concerns can manifest in A/B testing. We show practical adjustments to A/B testing toward inclusive software engineering and some insights into ongoing challenges. We all know and can easily imagine that biases exist, but how prevalent are they? Here is an example from a 2017 research paper by Rachel Tatum. We can see that Google's speech recognition app has been found to be more accurate for males than females, 70% more accurate actually. Another example next is face recognition. From a published 2018 paper, we can see that 3 commercial facial recognition systems from IBM, Microsoft Face++, have all been found to classify males more accurately than females. How much more accurately? The maximum error rate for lighter skinned males is 0.8%, while for darker skinned females is 34.7%. Knowing all this, our Windows experimentation platform is striving to identify and expose fairness and equality issues and to adjust the engineering processes and policies to compensate. A/B testing is a data-centric software engineering technique, which is being used by many organizations to design and improve their software. It is the gold standard for evaluating the causal impact of changes, empowering organizations to make data-driven decisions about their software. In its simplest form, an A/B test randomly assigns users one of 2 variants of a feature. Control group gets variant A, usually the default experience, and the treatment group gets variant B. User interactions with the 2 software variants are then recorded, and from that, metrics are computed and compared. If the A/B test was designed and executed correctly, the only difference between the 2 variants is the change in their specific feature. Our case study is about the Windows out-of-the-box experience. UBI helps users that are new to their Windows devices to set up their Windows accounts and services. Historically, UBI has utilized the blue design in dark colors, and we all heard that dark theme is trendy. You can see in this slide how interest has been exponentially rising for dark modes over time in different searches. But these themes can be reflective actually of gender biases, and you can see in the next slides metrics collected for different product users when asked to state their preferences show clearly that women prefer lighter themes and men darker. Back to our case study. In 2018, the UBI feature team considered an alternative light design featuring additional graphics and a lighter color scheme. In this slide, you can see the older, darker blue experience. And in the next slide, you can see the new version tested. The goal of these UBI design changes was to increase the Windows services LinkedIn sign up as measured by the proportion of users who sign up for these services. During the development process, the engineering team used an initial small-scale A/B test to evaluate the 2 designs using testing.com. The results were statistically powered to detect a roughly 15% change in the sign-up rates, with each variant having about 150 participants. They were recruited with the criteria of having recently purchased a Windows PC. The initial analysis of the results, a summary of which is shown here, indicated no statistically significant differences between the 2 designs. However, a closer examination of the data along demographic slices indicated large differences along gender identity. The 2 biggest differences were with the OneDrive screen and the Office 365 screen. For OneDrive, those self-identified as female had 18% higher opt-in for the light theme, while those self-identified as male had 21% lower opt-in. For the Office 365 screen, the self-identified as female had 39% higher opt-in for the light theme, and those self-identified as male had 39% lower opt-in. This A/B test unintentionally recruited a balanced 50-50 split in gender identity, which enabled these insights. However, in general, A/B tests are conducted with random sampling, which are unlikely to be balanced. For example, given the inherent and underrepresentation of females in computing data sets, the overall results would likely have been the blue design being better. There are many other products with dark light themes, and you can imagine potential biases exist elsewhere. How about themes or Outlook or Edge? The question is, how can we ensure our products are more equitable? Mary, our lead data scientist, is going to give us some insights from our platform. Mary?
Thanks, Irina. At Microsoft, we leverage randomized control trials to ensure new features we ship improve users' experience. You may be familiar with the randomized control trials we run in products like Bing, MSN, and other online services, but we also do it for Windows, the operating system, in our insider population. We have a well-established pipeline to help guide engineers through creating new features, running randomized control trials to understand its real impact on users and to deploy the winning variant. We call this end-to-end pipeline the Windows experimentation platform. So how does the learning we got from this case study play a role in the Windows experimentation platform? Next, please. First, it impacts how we plan for an experiment. If you're familiar with how experimentation works, one of the prep steps before launching an experiment is to determine how big a population we need to target. We do that through power calculation. What power calculation does is that it tells you to detect X% delta in a particular metric, you need to go to Y number of devices. Prior to this study, we used to only do power calculation at the overall level. But now we have learned from the case study that different segments can perform differently. We would do separate power calculations on key subgroups as well. Next, please. The second impact is that it impacts how we conduct our analysis. When looking at the scorecard, we feed in some key segments that we care about, both from the business perspective and the data science perspective. If there is any statistic movement in a subgroup compared to others, we will get alerted on the scorecard so that the data scientists on the experimentation team can partner with the feature team to do a deeper dive analysis to better understand if the feature is truly impacting a subgroup of the users more than the others. Next. In addition to the alerting itself, we can also slice the scorecard by segments we care about to take a holistic look at the impact the feature has on subgroups of the users. For example, this is the scorecard for the case study that Irina walked us through earlier. The first section of the scorecard is for overall users, the second is for female, and the third is for male. If the metric is highlighted with yellow, it means the metric has a statistically significant movement. We can see that at the overall level, there was barely any statistic movement for any metrics, but all the average metrics had statistic movement when we look at the gender-specific metrics. More interestingly, if we look at the female scorecard, we see that all the metrics have higher value in treatment compared to control, and it's the other way around for male section. This is exactly what Irina explained in the case study earlier. Of course, there were many other improvements we can do in the subgroups here. For example, gender should not be binary. And next. In the paper, we discuss several insights and ongoing challenges. One of the most interesting ones is anonymity. One of the commonly discussed approaches to help protect vulnerable subpopulations is anonymity. By not providing information like age or gender, organizations cannot use that information to bias their product or services. However, we have found that anonymity also makes it difficult for responsible software organizations to adjust innovation to better suit those populations. For example, in the case study we showed, without knowing the gender identity, the impact on female population would not be detectable in the experiment due to the natural imbalance in gender identity in the Windows insider population. In fact, all of our inclusive adjustments require knowing subpopulation membership. Consequently, approaches to safely share information about subpopulation membership, to promote trust in the information sharing, and to raise awareness about the potential benefits may be interesting areas for future research. We have more details as well as other interesting insights in the paper. Next. In summary, we're making many different investments to ensure we can capture unfairness or bias in experiments we run, both from the data science perspective and from the process perspective. From the process perspective, we have made a process change in randomized control trials such that in the experiment ship rooms, we require feature teams to review the results for key segments in addition to the overall level, so that we hold ourselves accountable for shipping products that are fair for our users. Hopefully by now you understand how the learning we got from the case study has motivated many data science investments as well as process improvements in the Windows experimentation platform. And with that, I'm going to hand it back to Irina.
Thanks, Mary. As you saw, our platform is adjusting its processes. Not sure if you noticed, this slide is the same as the previous one, but in a lighter color, white font. Which one do you prefer? To conclude our presentation, key learnings and insights. Adjust the sample size computation. label and segment data, surface notifications, but most importantly, I think it's a cultural change in the engineers to utilize the information and adjust their thinking decisions. Thank you. But most
all right, so welcome back. I have with me Irina and Mary, both from Microsoft, the first and second authors of this paper. So if you do have questions about their work, do please put them in the chat. So I do want to just to quickly say that I really like this work. I sit on an NSF NSERC panel on inclusivity in research, not just researchers, but research, and they're very much strongly advocating for more disaggregation of research results by subpopulations defined by demographic attributes like this. So, so you're going to get a lot of support from them as well. So, one of the challenges that you raise in the paper and in the talk is, how to achieve this data, the data that you need to disaggregate the results by demographic attributes during A/B testing, right? So how are you dealing with that challenge now, and do you see any early indications about, how we might go about doing a better job of that?
Yeah, that's a great question. And it's truly a challenge while we're doing the research, and it's still the challenge that we face. I would say we did go through quite a long way working with the lawyers that Microsoft has and like the PR department, CILA departments that we have, trying to see what are the ethical ways that can help us get more demographic information from our users. So currently, the way we used to get those information from Windows users is through the Microsoft account setup process. So when they're signing up, there was a couple questions about where you're located, what is your gender, what is your age group. Of course, they can choose to skip those questions and not provide an answer. They can also pick whatever they feel like. It doesn't have to be the ground truth. But those are the current ways that we use to collect those information.
Okay, that's excellent. I was worried that you were only able to have that information for internal users, and so the data that you had were only for Microsoft internal users. So it's nice that you are actually getting data from real users.
Yeah. It's not a high percentage. We get maybe 40 to 60% of the signed-in users that information, but we've seen the number growing in the past year or so.
So 40 as in 40 and 60?
Mm-hmm. Yeah.
Okay. Oh, that's pretty high.
It's not too bad, yeah.
You must have a lot of users, so it must have a lot of data.
We do appreciate our users for providing that information. That also helps us providing better service and experience for our customers.
Exactly. And so, do you have any early indications about how to use the results to, improve the tools, improve the experience of the users?
Yeah. As we stated in the paper, basically there were a couple policy changes and process changes we've made in the experimentation platform. Like for when we're reviewing the experimentation results for all the individual feature teams and product teams, they're required to look at subpopulations. So currently we have a set of predefined subpopulation groups, and in the ship room, prior to this case study, they only look at the overall result, and then they're good to go. But for now, they have to look at individual subpopulations. And if any of them have issues, they need to go back and do the deep dives and come back with an explanation. And if it's something very critical, then they need to get some high-level approval if they want to still ship the feature, or they need to go back and make feature changes before they can ship it.
Okay. Well, okay. So, some of this. But now you're talking about data that you have before you've shipped. So what data is that based on?
Oh yeah, we first run experimentation on the Microsoft internal employees,
okay.
and then we run on a group of users that sign up to be Microsoft insider population, we call it. And those devices, those users, they consent to get the most up-to-date Windows experiences. And from them, we get some first-hand experience on how they like it.
Okay. And so do you see any differences between that class of users, which is going to be fairly, early adopters, and other users?
Absolutely. Like as you said, those users are early adopters. It means that they're more technology.
Very technical.
Yeah, they're more technical. They are not the most representative of the retail population that we're actually giving our products to, but that's the best we can get at this point. And there are also many efforts that we're leading within Microsoft, trying to get a more representative population for the insiders.
Yeah, exactly. Okay, so we've got a couple of questions from Anita Sarma. So great work, congratulations. I was wondering if what you have done for the gender differences can also be extended to other demographics, including high-low SES.
What does SES stand for?
What does SES stand for, Anita?
Yeah.
There's a time delay in case you can't tell.
Yeah, and overall, yes, we do. We don't do just gender. We also have age group. We also have the price band for the device, the region, or what types of like the brand of the device, stuff like that.
Right. So yeah. So SES is social economic status. So I don't know whether any of the questions that you
We don't have
asked,
that.
We don't have
yeah.
that.
Well, not directly, but it'd be interesting if you could, if there were a way to identify some kind of proxy for that.
Yeah.
Second question was, do you have any thoughts about why these differences arose in your study? Why are there gender differences? Why are there age differences? Why are there region differences?
I think for the particular case study that we presented, it just turns out that females like the white design more than the darker design, and for male it's vice versa. And interesting enough, the way we identify that it could potentially be a problem is actually within Microsoft while we were designing those features. Turns out that the designer team always vote for the lighter design, and the developer group always vote for the darker design. And turns out that developer teams are always males, and the designer teams have more females. So that's when people started to realize, oh, that might be a gender issue rather than a discipline issue.
Interesting.
And then so we run those studies, and turns out that it actually is. I think the reason why females like the lighter colors might be more on the psychological field study.
Yeah. So she's done quite a bit of work on gender differences and in preferences for software and tools, etc. So there is this question or consideration that it may be related to cues and how easy it is to forage for these in the UI, right? How easy it is to see things.
Very interesting. Yeah, should look into those.
Yeah. So you mentioned a second challenge of reaching like hard to reach underrepresented subjects. And I don't know if this is in the general user population or if this is in the internal population. And how are you trying to go about that? Is it more of an issue in the general user population, or is the focus really in the internal population?
Yeah, I think eventually we always strive to get information from the general population, and the fact that we don't get a representative population for like the real retail users that we get has always been a concern, and we always strive to find ways to mimic the real population we're trying to serve.
Right. Yeah, if there's any way to communicate why are you using it and why it is to their advantage to give that to you. So any last parting comments? 30 seconds. Any last parting comments that you want the audience to take away from this talk?
Irina, do you want to go?
No, it's just thank you very much for actually attending this and seeing our video.
Awesome.
Yeah.
It's been a great work.
Thank you.
Thank you.
Like I said, this is the future, this disaggregation of information. So thank you, and continuation will